Have you ever listened to an orchestra piece by Schubert, Mozart, or Vivaldi, where all the instruments of the orchestra play together to give you an harmonized melody? For my PhD project, I study how two different systems of our body play together against leukemia. In our body, we have many different systems that cooperate to maintain homeostasis, which is a state of balance needed for our body to properly function. As an orchestra, we have many instrumental families that play together to give a melody. Imagine that the winds of the orchestra is the immune system, while the strings of the same orchestra is the nervous system. These two constantly communicate with each other to fight against inflammation, infection, or cancer. In a particular type of cancer called acute myeloid leukemia or AML, where the tumor accumulates in the blood and in the bone marrow, and the overall survival of the patient is very poor, we lose the cooperation between the immune system and the nervous system, and so we lose our melody. In my PhD project, I focus on particular instruments of the winds and the strings of the orchestra of our body. From the immune side, I study the innate lymphoid cells, or ILCs. These cells are known to have a plethora of different functions, and they are also able to kill tumors. While from the nervous side, I studied a molecule that is called Brain-Derived Neurotrophic Factor, or BDNF, which is mostly known to maintain the fitness of the nervous system. In leukemia, innate lymphoid cells do not function anymore and they cannot kill the tumor. At the same time, we know that neurodegeneration happens in the patients, meaning that we have a disruption of the nerves that leads to a dramatic loss of BDNF. My hypothesis is that if we are able to supply again BDNF to the innate lymphoid cells, we could restore their anti-leukemic functions. To do this, I have two models, an in vitro model and an in vivo model. In vitro, I isolate the innate lymphoid cells, I treat them with BDNF, and I measure the cytotoxic molecules that they are able to secrete against the tumor. In vivo, I have a leukemic mouse model in which I inject both innate lymphoid cells and brain-derived neurotrophic factor, and then I measure the advantage of survival of these mice. Overall, my PhD project aims at setting a novel strategy with which we can fight AML, in which the winds and the strings of the orchestra of our body restore their interplay to fight leukemia and thus restore our melody.